All right, so we're continuing with dilations here. In this case, I want to look at some different types of situations you might come across. For instance, when they're talking about the center of dilation and then also the distances between our pre-image in the center of dilation and then also the image in the center of dilation, okay? It says the distance over here, the distance from the center of the dilation to each point of the image is equal to the distance from the center of dilation to each corresponding point of the pre-image figure times the scale factor, okay? Now, all that really means is if 0 here, or O, sorry, not 0, O over here is our center of dilation, if the distance from O to B is Y, okay, whatever that generic distance happens to be, then the distance from O to B prime, the image here, would just be the scale factor times Y, okay? So if the scale factor is 3, then the distance would be 3 times as far, okay? So if the distance from O to B, our pre-image, is Y, then the distance from O to B prime would be K times Y, the scale factor times Y. Now, what we can do is we can use that to help us with a certain situation here. Now, I realize most of these examples are going to be worked out for us, but maybe we can explain where they're getting their answers from. So it says the dilation is centered at, at O, so that's our center of dilation here, and we have a scale factor of 3, okay? So K is 3. Our scale factor is 3. And they tell us that the distance of OA is 6, the distance of OB is 7 centimeters, and the distance of AB over here is 8. And we're wanting to find these other distances that they're asking us to look for. So A prime, B prime, A prime, B prime. Well, that distance is just going to be scaled by a factor of 3. So if AB over here is 8, then A prime, B prime is just going to be 8 times 3. Well, what's 8 times 3? 24. So this distance here is going to be 24 centimeters, which is what they have there, okay? Then, if we have OB primed, okay, so the distance from O to B primed here, that's also going to be scaled by a factor of 3. So if OB is 7, then O to B prime would be 7 times our scale factor of 3. Well, what's 7 times 3? 21. So the distance of O to B prime would be 21 centimeters. Okay, similarly, O to A primed here is just going to be scaled by a factor of 3 from O to A. Well, O to A is 6, so this would be 6 times, okay, keep in mind we're talking about the whole side, just like in the last example, 6 times 3, which is 18. So that distance from O to A prime would be 18. Then if we're just talking about the distances in between, so this next part here, it says, what about the distance from just A to A primed? Well, if the whole distance is 18 and this little piece is 6, can't I just subtract the 2? Yeah, 18 minus 6 is what? 12. So this distance from A to A primed would be 12. Then what about B to B prime? Well, a similar argument here. Okay, let's use a different color, maybe yellow. Why not? If this is 7 and the whole distance is 21, then can't I just take 21 minus 7 to find this guy? Yeah, okay. Well, 21 minus 7 is 14. So B to B prime would be 14, okay? So all it is scaled according to what the given scale factor is, okay? In this case, it was we multiplied everything by 3. Then as far as what is the ratio? Well, what would the ratio be of OA to AA primed, okay? Well, OA is 6, then A to A primed is 12, okay? Well, what's 6 to 12 going to be? Well, 1 to 2, right? If I reduce that down and think of it in terms of a fraction, 6 over 12 reduces to 1/2. So OA to AA prime would be 1 to 2. So that's just different situations we can run in there. Then what I want to do is I want to skip down and look at the different situations we can have depending on whether we're talking about a center of dilation, so where are we dilating from, okay, that center of dilation, whether that's on the inside of a figure, it's on the figure itself, or it's outside the figure, okay? So depending on where the center of dilation is located, what can happen, okay? Now it says a dilation, there we go. A dilated figure's location greatly depends on the location of the center of dilation. We've already looked at the center's impact on lines, okay? But what we can do is take the center of dilation, wherever that happens to be. In this case, let's look at this example here, and extend it out so that it connects with our pre-image. In this case, I'm going from O to B, O to A, and O to C, and that's going to help us determine where our image is going to be. Okay, so notice it connects B and B prime, it connects A and A prime, and it also connects C and C prime. Okay, that should always work. We should always be able to connect our center of dilation with our pre-image and our image. Okay, those points should always be, in a sense, collinear. Okay, now this is on the inside, so this has the center of dilation here. Maybe let's use a different color. This has the center of dilation on the inside of our pre-image. Well, our pre-image was this guy. Okay, and what happened is they reduced it. In this case, we have our A primed, our B primed, and our C primed, okay? But we have our dilation on the inside, okay? Same thing over here. They have their center of dilation here, okay? But in this case, they're actually enlarging the figure. But notice, I can connect to my pre-image and then to my image here, B and B primed, A and A primed, C and C primed, okay? So we start with this pre-image, and then they enlarge it. They enlarge it to get A prime, B primed, and C primed. Okay. Then what happens if it's actually on the figure? Okay. Well, here it's actually on the figure. We're at O, and then I can still connect B with B prime. I can still connect A with A prime, and I still connect C with C primed. Okay. In this case, they're enlarging the figure. Okay, so in this case, we start with our pre-image here, and then we enlarge it to our image, A prime, B prime, C prime. Okay, so that's what it looks like if the center of dilation is actually on the figure. Okay, now if it's outside the figure, that's probably the most common one here. If the center of dilation is on the outside of the figure, it still works here. We can still connect B with B prime, we can still connect A with A prime, and we can still connect C with C prime. Okay, but we're starting with, in this case, this would be the pre-image, and then we enlarge it. We're enlarging it to A prime, B prime, and C prime. Okay, but it all still connects there. Okay, so that's what it looks like. So if it's on the inside, that's what it looks like. If it's on the actual figure, so it's on our pre-image, and then if it's outside the pre-image, that's the different cases we can look at. Okay, now let's just look at an example of one of these. Let's look at one that's on the outside, and we'll do some other examples in class. This example here is saying we want to dilate this with 0, or I keep saying 0, O, because it looks like a 0. O is going to be our center of dilation, and then we're going to scale that by a factor of 2. In other words, we're going to double the size of the figure. Okay, let's just look at that example. Now, when you're working through this one's on the outside of the figure. Again, what did we notice up here? We could always connect our pre-image and our image with the center of dilation using a straight line. That's going to help us out when you guys are working through these figures here. So you might want a straight edge or a ruler. In other words, I need a straight line that's going to connect through here, a straight line that's going to connect through here, and a straight line that's going to connect through here. Now that's not going to be perfect because I'm drawing it by hand, but notice they're doing the same thing over there. Okay, let's see if we can recreate the figure here. Now the best way to go about this is count. Count the number of spaces it takes to get to A, B, and C. 1, 2, 3, 1, 2. So to get to A, I have to go over 3 and up 2. Well, what are we trying to do to this figure? We're trying to double its size, right? So if I take what I did before and doubled the distances, that's going to double the size of my figure. So instead of going to the right 3 and up 2, what should I do? Right 6 and up 4, right? So notice this ratio here, my rise over the run. If we think of this in terms of slope, the rise over the run is I'm 2 over 3. So if I double the slope, that would really be 4 over 6. So to get to A primed, I really need to go over to the right 6 and up 3, or excuse me, up 4, okay? Now I'm losing track of what I was saying. So we're going to the right 1, 2, 3, 4, 5, 6. That's double the distance. And then we're going double the distance up. 1, 2, 3, 4. So it lands right there. So that guy right there, that would be my A primed. Okay? Then, same thing with B. I'm going to count that distance. 1, 2, 3, 4. So I'm going to the right 4 and up 1. So my rise over 1 is 1 over 4. Now, if I double that, okay, I should actually mark this as times 2, not equals. That's my bad, guys. Times 2, because that's what we're really talking about, is equal to this. Okay, same thing here. We're multiplying this by 2. So if I multiply both of these, the top and the bottom, by 2, I get 2 over 8, right? In other words, I got to go over to the right 8, and I got to go up 2. So let's use a different color here. Maybe let's use green. So I'm going over to the right 1, 2, 3, 4, 5, 6, 7, 8, and I'm going up 2. Well, notice it's lining up with our lines, correct? Then lastly, let's see how we can get to C. Okay, let's use this guy. So to get to C, I'd have to go over right 1, 2, and down 1. Well, that slope's going to be negative, right? Because my rise is down. So I'm going down 1, but I'm going to the right 2. So if I multiply both the top and bottom by 2, what do I get? Negative 2 over 4. Okay, so in this case, to get to C primed, let's use orange, I got to go to the right 4, 1, 2, 3, 4, and I got to go down 2. We'll see how it lines up real nice like that. Now what we want to do is connect our A prime, B prime, and C prime, which I didn't label this, right? So this should be B prime, there we go, and C prime. So connecting this, whoops, let's try that again. That's a little better. Now I've doubled the size of the figure, just like they have there. Okay, so that would be dilating. This one's on the outside, but of course you can apply the same thing to when it's on the inside or when it's on the actual figure. Okay, now the next thing I want to look at is what happens if the scale factor is negative. Okay, a dilation with the center of 0 and a scale factor of k is a transformation that maps every point P to a plane to a point P prime. Okay, now if P is not on the center of O, then P prime lies on the opposite ray of OP. All this is saying, guys, if we're dealing with a scale factor that is negative, it just goes in the opposite direction, okay? So if we have 0p and we're trying to, let's say, enlarge the distance of 0p by a negative scale, then it would enlarge in the opposite direction, okay? For instance, if I look at this guy here, this says we have a dilation at the center O, center of dilation O, and it's being scaled by a -1. So is it being enlarged? No. When I enlarge something, I have to have more than 1. It has to be greater than 1, right? Is it being reduced? No. It's not being reduced because this number, it doesn't matter what the sign is, we're just saying that the actual value has to be less than 1. In this case, it's going to be the exact same figure, but in the opposite direction. So that's what they're showing here, okay? So I have A, B, and C, and notice they're using the same lines here. I should try that again. They're using the same lines here. So then if I extend that in the opposite direction, that's what we're going to use to find A prime, B primed, and C primed. So they're making the same figure in the opposite direction. It's not enlarged or reduced because it's a -1. So A is going to, or A, or 0, man, O to A here, this distance is going to be the same as the distance to O to A primed because we're not doubling anything or reducing anything. Same thing here, O to C primed, O to B, and O to B primed, okay? Then they just recreate the figure in the opposite direction, okay? Now, what do you notice about that? It's a rotation of 180 degrees, okay? So when we're scaling something by a negative, okay, when we're scaling by a negative, it's really like a rotation of 180 degrees, and then we could enlarge the figure or reduce it. For instance, this is the same idea, except now it's a scale of a -2, so it's a rotation of 180 degrees in the other direction, but the figure doubles. So it's exactly the same thing we just talked about in this example up here, except it would be in the opposite direction, okay? So it would be in the opposite direction, okay? Notice everything still connects. A connects with, whoops, there we go. Let's try that again. A prime connects with A, C prime connects with C, and B prime connects with B. It's just in the opposite direction, and the distances in the figure size doubles because we're scaling it by a -2, okay? Now, the last couple of things we want to look at here. Let's see if we can get that guy. I don't want to talk about that. Let's just look at an example of scaling it by negative up here, and then we'll look at some of the coordinate rules, okay? So let's take this example over here. Same idea. We want to be able to connect everything. So what I would always start off with is with a straight edge, connect O with A, connect O with C, and connect O with B so that you have some lines to work with, and we're going to see how we match this figure here. Okay, let's just look at this and see if we can tell. So again, find the distance from O to A. Well, O to A is over 2 to the right and up 2 to get to A. Well, as a slope, that would be 2 over 2, right? Well, if we're going to be doubling the figure, because that's what it says over here, we're scaling it by a -2. If we're going to be doubling the figure here, then I need to multiply my slope here by 2. So really, we're going to end up going to the right 4 and up 4, okay? So my rise over run would be 4 over 4. But here's the catch. If we're scaling it by a negative, in this case a -2, it's in the opposite direction. So instead, I'm going to be going over to the left, 1, 2, 3, 4, and I'm going to be going down 1, 2, 3, 4. Okay, so notice it's the exact opposite. To get to A, I had to go right 2 and up 2. If I'm scaling by a negative, then I have to do the opposite. Left 4, down 4. Okay, left 4, down 4. Okay, so that's how I'm going to get to that guy. Is I have to go by left 4 and down 4. So you could say, in a sense, that this is going to be a negative, okay? Left 4 and down 4. So then that gets me to my A prime, which is still on this line connecting. Okay, it's still on that line connecting. Okay, let's see what we can do to find the distance. In a sense, we're finding the slope of the distance B. I have to go over 1, 2, 3, and up 1. Okay, so my rise is 1, and I'm going to the right 3. Well, we're scaling it by 2, so multiply by 2. Top would be 2, bottom would be 6. But we had to go to the right 3 and up 1, right? So what's the opposite? Left and down. Okay, left and down. In this case, we want to go by twice as much, so it'd be our rise is 2 and our run is 6. So we're going to go to the left 6, 1, 2, 3, 4, 5, 6, and down 2. So that gets me to my B, and notice my B prime, my O, and my B connect. Okay? Then to get to C, we have to go over to the right 1 and down 1. So we have to go to the right 1 and down 1. Well, that's a negative slope, right? We're going down 1 and to the right 2. Well, we need to double that, so this would give me a -2 over 4. Whoa, what happened there? A -2 over 4. Okay, except we're going to do the opposite of that. Okay, so think about changing the signs. We're doing the opposite of that. So if I had to go to the right 1 and down 1, I need to go, in this case, if we're doubling it, to the left 2 and up 4. So we're going to the left 2 and up. Oh, it was right 1 and down 1. What am I doing here? There we go. There we go. So now this changes over here. This would be a 2, okay? Sorry about that. So we went to the right 1 and down 1. So if I double that, that'd be -2 over 2, but we're doing the opposite, so it'd be left 2, up 2. There we go. Sorry, guys, my technology messing with me, and then I messed that up. My bad, guys. So we left 2, up 2. So now this works out, and my C, my O, and my C prime, they all connect, and then we can trace the figure. Okay, so this would double the figure. We enlarge the figure. It's just a negative in the opposite direction. Okay. Last thing I wanted to talk about is the coordinate rules. Okay. With a dilation, okay, a dilation versus a stretch. Well, let's talk about that first. A dilation versus stretch. Remember, a dilation keeps the size. The size is, or does not keep the size, keeps the shape, but the size can enlarge or reduce. So it keeps its shape, but the size can enlarge or reduce, okay? A stretch does not necessarily keep the size or the shape. So a dilation keeps the shape, but not necessarily the size. It can enlarge or reduce. If it keeps the proportions the same, that means whatever I scale x by, I also scale y by. In other words, whenever I am scaling both the x and the y, I'm really multiplying the x and y by something. In this case, they say if I scaled this by 5, I'm multiplying the x by 5 and the y by 5. But notice, am I multiplying the same thing to both? Yes. This is saying I want to reduce this by a third because when we multiply by a third, it's going to get smaller. Is it multiplying a third to both? Yes. This says a -3. Is it multiplying a -3 to both? Yes. So when we have a dilation, it's going to multiply the same thing to both the x and the y. Not so much with a stretch. With a stretch, we can multiply by different things. That's why it's distorted, guys, okay? So if I multiply by different things, that's a stretch because it distorts the image. But going back to this, what that allows us to do is we can use this as a coordinate rule to figure out what a point's going to be when we dilate it, okay? So if I take a set of points like they have here, this says if I wanted to dilate this by 2 with my center O here, so we have a scale factor of 2, that really means I'm taking each x and y and multiplying it by 2. So if I'm scaling it by 2, that really means I'm multiplying it by 2. So we could take the point 0, 0, that's our center of dilation, and we could plug that in, okay? Or in this case, that's just going to stay the same. But we could plug that in, and then we'll come back to C. I'm going to come back to that. Let's just plug in O. Okay. So we could plug that in. 2 times 0 is 0, and 2 times 0 is 0. So when I dilate, our center, notice that doesn't change. That's what we talked about in the last video. Our center of dilation doesn't change when we dilate. However, they also give us a point C. We could plug that in. 2 times 1. And 3 times, or whoops, go back. Come on, Mr. P. 2 times 3, that's what I'm plugging in. Then when we multiply that out, we get 2, 6. So when I dilate this point, 1, 3, it changes to 2, 6. Well, that makes sense. Everything doubled. 1 times 2 is 2. 3 times 2 is 6. So that doubles. Now notice it still connects, okay? And in fact, it keeps the slope. It keeps the slope. To get to C, I had to go up 3 over 1. Then to get to C primed, I have to go up 6 over 2. So it maintains that slope. It's just doubled. Okay? So anytime we want to dilate a set of points, just take the scale factor and multiply that to both the x and the y.